I'm Anil Kumar, and in this video we'll understand some basic concepts about piecewise function. So we're looking into two types of questions here. One is what are piecewise functions? The other one is how to sketch piecewise functions. Now, as the name suggests, piecewise functions, that means functions made up of two or more pieces. It's kind of like this. Let's take an example to move forward. Let us say we have a function f of x, and this function is defined as let us say just value of x for let us say x greater than or equal to 0, right? And for a value less than 0, let's define this as 1 over x, okay, for the value x less than 0, okay. So we have defined a function f of x whose value is x if x is greater than or equal to 0. So I have a graph paper here. So that means on the right side of origin, for every value of x including that point, the function value is x. So it's kind of a straight line which I could draw like this, right? So that is the function where this point is included in the linear function x. So that is my first piece of function. The other piece of the function is when x is less than 0, it is 1 over x. So 1 over x is kind of a reciprocal function, right? So we could draw like this, kind of like this, right? So let me just sketch this function here. So it will be kind of like this, okay. So that combination of two pieces becomes the function f of x. As clearly you can see, in this function, we have discontinuity at origin. Individually, in their domain, both functions are continuous, right? But they have discontinuity at the point where they're supposed to join. So there, at x equals to 0, we find that there is a discontinuity. Now when you have two pieces like this, as you can clearly see, we have a discontinuity, and this discontinuity will be referred to as infinite discontinuity. Infinite discontinuity, right? Let me take another example of pieces which could be joined together. For example, if I have a function g of x which is equal to, let us say, absolute value of x plus 2 if x is less than equals to minus 1 and is equals to minus x squared plus 2 if x is greater than minus 1. In that case, let us sketch this function also and see how does this function look like. So if x is minus 1, if I substitute minus 1 here, we get a value 1, correct? So at minus 1 plus 2 is 1, right? So minus 1, we get a value 1. If I write another value minus 2, at minus 2, it will be 0. So this will be this point, right? If I write minus 3, it will be minus 3 plus 2 plus 1. So the absolute function will be kind of like that. Do you see that? So, and then I can move forward in this fashion. So that becomes absolute function on the left side of minus 1, right? Now on the right side, we have a parabola. So if I substitute values here, let's say if I substitute minus 1 here, minus 1 square is plus 1, and minus 1 plus 2 again gives us plus 1. So it starts from here, but we'll put a hole here since that part is not included in this parabola. Do you see that? If I would write 0 here, I get 2 as my value, 1, 2. And then for 3 square is 9, and 9 minus 9 plus 2 is 7, right? So what we get here is a function which is kind of at 3 we have 7. So 1, 2, 3 and 1, this is 5, 6, 7, kind of like this, right? So we could write, and at 2, let's calculate at 2 also. At 2 the value will be minus 4 plus 2, which is minus 2. So at 2 we'll have minus 2, and at 1 it is minus 1, right? So at 1 it is minus 1. So at plus 1, sorry, at 1 it is plus 1. So what we see here is that the function is kind of like this, right? So it's a parabola which is opening downwards. However, in this particular case, both these pieces are joined together at minus 1. So this actually becomes a continuous function. So what we learned here is that piecewise functions could also be continuous. They could be discontinuous and have a discontinuity which we call as infinite discontinuity. Let me take one more example here. Let's say h of x, and let me define this function as equal to let's say minus 1. Let me write a bigger value. Okay, so let me say minus 4 when x is less than equal to minus 2, and let it be plus 4 when x is greater than minus 2. Now let's kind of sketch this function. What you get? Now in this function, at minus 2, this value is included for minus 1. So at minus 2, the value of the function is minus 4, so which is right there. So this point is included, and it's a constant value. So it will be kind of like this. Do you see that? So this is the left side piece. Whenever x is less than minus 2, it is a constant minus 4. However, for a value of x which is greater than minus 2, it is plus 4. So at a value greater than minus 2, that is not equal to 2. So we'll make a circle which is not filled in, and we'll draw a line like this. So this particular function becomes h of x. Do you see that? So here we again see that the function is discontinuous, and this kind of discontinuity is called jump discontinuity. So what we see here or learn here is that a piecewise function is made up of combination of different pieces. In their own interval they are defined. So for example, x is defined in this interval greater than equal to 0. 1 over x is defined in the interval less than 0. So each piece is defined in its own interval. Now these piecewise functions could be continuous or could be discontinuous. If the two pieces, like in our case of g of x, have the same value at a point where these pieces are supposed to join, right, or not, if they join together at that point, then they are continuous, as you have seen in this example g of x. Otherwise, these two pieces, if they don't join at the point on either side which they have been defined for, in that case they have a discontinuity. We may have discontinuities of different kinds. We learned two types of discontinuities here. One is called jump discontinuity. The other one is called infinite discontinuity, right? So with this, we close this video. We'll take a few more examples on piecewise functions and further explore this topic. I'm Anil Kumar. Feel free to share your questions and doubts. Thank you and all the best.